Here's a hazing ritual for new elves at the North Pole. The new elf shows up here and asks another elf, hey, which of these buildings do I go into to get the candy stripes? And it says, oh, keep going east for 12 buildings and it'll be the one on the right. If he goes east around the North Pole, he's going in circles repeatedly. Going east is not the same thing as going straight. If you start standing on a sphere and you march in a straight line, it makes sense that you would go all the way around the world, right? You would make something the size of the equator. But if you're not standing on the equator, that's not the same thing as going east. Suppose you're in Boston here and you start going east, you would be going in this circle. But if you go straight, you're going in this circle. And this circle will cross the equator. Now, right at this moment, going on the path, the great circle, and going east are the same direction. So if you had two people start here and say, okay, we're both going to face east and then walk straight. Now, if the world were flat, they would never meet. But they are going to meet twice as they complete their circle of the globe. So this is a case of parallel lines intersecting, because what are parallel lines on a sphere? You actually have to think about that, right? Because you'd think that this path going pure east would be parallel. Well, in 3 dimensions it's parallel, but if you're looking at the surface, this is very much a curved path. So the surface of the Earth is an example of non-Euclidean geometry. Parallel lines meet.